Hello everyone, my name is Roya and today I'll be presenting my Capstone project, an analysis of greenhouse gas emissions in Canada. This project covers national and regional emission trends up to the year 2023. The data for this project comes from Environment and Climate Change Canada's official website. I use Python, specifically Pandas and Boca for data analysis and visualization. The presentation itself was created and recorded in PowerPoint. The main goal of this project is to understand how greenhouse gas emissions in Canada have changed from 1990 to 2023. I also compare emissions across provinces and territories for key years 1990, 2005, and also 2023. Another focus is to identify which regions and sectors contribute most to emissions. And finally, I look at emissions per capita and emissions relative to GDP to understand how individual and economic factors play a role. To begin the analysis, I first imported the datasets on emissions, population, and GDP. I cleaned the data by removing extra rows and columns. I also converted some of the columns into, for example, date-time formats to make time series analysis easier. And lastly, I grouped the data by year to prepare for regional and trend-based insights. I imported three key data sets. The first one includes national greenhouse gas emissions in Canada from 1990 to 2023. The second one covers emissions per person and per unit of GDP, allowing for deeper analysis. And the third data set shows regional emissions across provinces and territories. Each of these data sets was loaded into separate data frames, DF1, 2, and 3. And to make the visualization more interactive, I used the book library. And with functions like figure and show, I was able to create and display customized plots. I also used tools like crosshair tool to help track data points more accurately and hover tool to display values when the user hovers over the graph. After importing the data, I cleaned all three data frames. For DF1 and DF2, I removed unnecessary rows at the top and bottom, specifically rows with indices 0 and 1, 36 to 39. And for DF2, I also dropped extra columns labeled like unnamed 1 and unnamed 3. In data frame 3, I removed rows 0, 1, and 15 to 18 to keep only the useful regional data. Then I renamed columns in all three datasets to make them easier to work with. For example, I used simple names like date, provinces, and renamed unnamed columns to more meaningful labels. Next, I prepared the data for analysis. First, I converted the date column into proper date-time format to make time series analysis possible. I then extracted the greenhouse gas emissions column into a variable called gas emissions. In the second data set, I converted the GHG per person and GHG per GDP columns to numeric values. For the regional dataset, the third one, I ensured that provinces' names were stored as strings and converted the values for 1990, 2005, and 2023 emissions to numeric format. And finally, I created three dictionaries, source 1, source 2, and source 3 to use for interactive plotting with Boca. As I mentioned, I use Boca to create a combined scatter and line plot with the x-axis showing time and the y-axis showing emissions in megatons. And I also customized the plot with a title, access label, and a clean look by removing vertical grid lines. The y-axis range is set between 500 and 800 to keep the focus on relevant values. Interactive tools like crosshair and hover make it easy to explore the data by showing exact emission values as you move your mouse. This figure shows a plot of Canada's total greenhouse gas emissions from 1990 to 2023. Looking at the national data, there are two key takeaways. First, from 2005 to 2023, Canada's total greenhouse gas emissions decreased by near 8.5%, which shows some progress in reducing emissions. But over a longer term, from 1990 to 2023, emissions actually increased by 14%. The next figure shows two index trends over time: greenhouse gas emissions per person and per unit of GDP. Again, using Boca, I created a combined scatter and line plots with different colors for each trend. The x-axis shows time and the y-axis shows the percentage change, which helps us understand how these indicators evolved over time. I removed vertical grid lines to keep the chart clean and focused, and interactive features like hover and crosshair make it easy to explore specific values. And here are the key insights from the per person and per GDP data. Between 1990 and 2023, greenhouse gas emissions per person in Canada decreased by 21%, which suggests improvements in individual carbon footprints. Emissions per unit of GDP also fell by 45%, indicating that Canada has made progress in breaking the link between economic growth and environmental impacts. The last figure shows a grouped bar chart showing greenhouse gas emissions by province and territory for the years 1990, 2005, and 2023. Each year is represented by a different colored bar grouped side by side across regions. The legend is positioned at the top right and lets you click to hide or show specific years for clearer analysis. And provinces and territory names on the x-axis are rotated to improve readability. In 2023, the top 5 emitters, Alberta, Ontario, Quebec, Saskatchewan, and British Columbia, accounted for 92.5% of Canada's total greenhouse gas emissions. Ontario and Quebec showed reduction compared to 1990, with emissions decreasing by 11% and 6% respectively. Based on the findings, here are some simple recommendations. The first recommendation is to improve national efforts to reduce emissions. Although emissions have decreased since 2005, larger and more sustained cuts are necessary to meet the 2030 targets. The second recommendation is to focus on the highest emitting provinces, such as Alberta and Ontario, since they contribute over 90% of Canada's total emission. The third recommendation is to support provinces and territories where emissions are increasing to prevent the rises from offsetting national progress. Another recommendation is to promote technologies and practices that allows economic growth without increasing emissions. And the final recommendation is to continue using indexed emission trends to transparently monitor progress and guide policy decisions. Thank you everyone for your time and attention.